Computer, what time is it?
Friday, 1525.
Computer, what's the weather?
39.45 degrees.
Computer, tell me a joke about Louis Rossmann and Bill Clinton.
Why did Louis Rossmann and Bill Clinton start a repair shop together? Because they both know a thing or two about fixing cracked screens and political scandals.
Computer, turn light on.
Light is on.
Computer, turn light off.
Light is off.
Welcome back. As you know, I am Eli, the computer guy, and in this session, I'm going to show you how to build a voice-controlled app using Python that will also be able to respond to you in the English language. So basically, we have a Python script here. I am able to speak to the computer. The computer parses what it is that I said. Then, based off of what I say, it then triggers different functions to fire off, and then it gives me some type of verbal response. It'll tell me what the weather is. It'll tell me what the time is. It will tell me a joke. And when it turns a light on or off, it will tell me that at least it thinks that it's turning the light on or off. And we were able to do all of this with Python. So one of the important things that I try to get across to new students is that when they look at the world of technology, they see all of these very complex subjects and complex technologies, and they think, oh my God, how am I ever going to be able to do X, Y, or Z? How am I ever going to be able to build artificial intelligence? How am I going to be able to build some kind of voice recognition system? How am I going to build the next GPS? And what I keep trying to tell all the youngins is, remember, AI is hard, APIs are not. And frankly, for most of you, you're going to be dealing with the APIs. You do not have to try to figure out how to build the next OpenAI or ChatGPT or whatever else. You have to figure out how to make an API call to get the access to the resources that those platforms are providing, so that you can then bring them into your code. And so one of the really interesting things nowadays is you see these really complex technologies, things, again, such as voice recognition. It's like, wow. The amazing part in the modern world of technology is for voice recognition in your Python code, you literally install a couple of modules and write a little bit of code. You have to install a module called PyAudio that allows you to be able to actually pull in audio from your microphone. You then install another module called speech recognition, or a package called speech recognition. In there, there's an option for Google. That's what we're going to be using today. And that's basically it. Pi Audio allows speech recognition to be able to get the audio that's coming in from the microphone. Speech recognition then takes that audio, turns it into ASCII text, and then once we have ASCII text, we can just deal with it really, really easy. Again, and that's one of the things to really be considering in the modern world when we're using these computers is basically, can you take complex information and somehow turn it into text? Can I parse a picture? No, that's very difficult. Can I send a picture up to Microsoft's Vision services? It responds with text in a JSON format. And then can I parse text in a JSON format? Oh yeah, I can do that in about 5 minutes. That's incredibly easy. And so that's one of the things that I want you to take away today from this project that I'm going to be showing you is basically this idea is that you can use these modules, you can use these services that have already been created. Basically with that, you can turn things into just generic text. Once you turn it into text, you can parse it just like it's generic text because it is generic text, and then you can fire off events to happen, and what you find out, it's actually really pretty darn simple. Again, AI is hard, APIs are not, and so in this class today, we're going to go through the script. I'm going to show you how it works. We're going to be dealing with the operating system, so we use the OS module. That's how we get the time. We're going to deal with a REST API. So we're going to go out to a couple of REST APIs in order to get what our current location is, and then to get the temperature. at our current location. We are going to use OpenAI's API for that whole joke functionality. If we want to tell a joke, we are going to use Open API in order to do that. And then for turning the light on or off, we're going to use something called the serial module. The serial module is going to communicate with our nice little Arduino down here. The Arduino is connected to what's called a relay. The relay is connected to our light, and that is what turns the light on or off. And so I'm going to show you how all of this works, again, to give you the idea of not just how this particular project works, but how you can build something yourself. Now, the core to today's project is a module called speech recognition. As I'm doing this recording, they're at version 3.10.1. So basically, you can use pip or pip3, install speech recognition, and this will then install this package onto your system so that you can use the module. One of the nice parts with speech recognition is that you can actually use a number of different speech services. So you will have heard me talk about in the past something called SOA, or service-oriented architecture, right? This is an architecture style that really became prominent about 15 years ago. The idea being is that you should be able to write your code, you should be able to design your platform, and whatever functionality that that platform or that code needs, you should be able to swap it out relatively easily, right? So if you're using Twilio, so Twilio is something for SMS messages, basically text messages. So let's say you're using Twilio within your application, and for whatever reason you need to stop using Twilio. Maybe your PayPal account will no longer send money to them, or Twilio, they jacked up the price and it's just too expensive for you, whatever else. In service-oriented architecture, the idea is you should be able to go out to another SMS API provider, find the one that you want, and basically with a number of lines of code, just be able to then, paste that into your code so that you're now using that new provider instead of Twilio. The idea being all of these services, you should be able to mix and match and change around with relatively few problems with your system when you do it. You're not going to have to do massive migrations or anything like that. One of the interesting things with the speech recognition module is that you see how many options you have in the modern world for speech recognition, right? You have Sphinx, you have Google Speech Recognition, you have Google Cloud Speech API, Wit, Azure Speech, Bing Voice, Houndify, IBM Speech, Snowboy, TensorFlow, Vosk, OpenAI Whisper, and Whisper API. These are all different voice services that will take your voice and turn it into text. Now, there are good parts and bad parts for some of these. Some of these actually are able to work offline. Some of these are going to cost you a little bit more money. Some of these are going to be part of a larger cloud infrastructure that might be useful for you. Again, if you're already in the Microsoft world, using something like Azure's speech services might make sense because you're already in the Azure world, right? The idea being is you pick the best speech service for what your particular situation. So these are a number of different options here, and you can use these options with the speech recognition package. But we are going to be simply using Google Speech Recognition today. Now, there's a couple of things to keep in mind when you do this. One, it is an API call. So with this Vosk down here and OpenAI Whisper that works offline, these are offline, which means it just runs on your computer and you do not need internet access for those to function. So if you're using something that's online, right, you do have to have an internet connection for this to function. If my internet connection goes down, that script that I show you will not work. The other interesting thing with this is with speech recognition, I like this because it's very easy to get up and running. Again, I like to show you folks easy stuff. You can make your life more complicated, right? Well, a nice part with this is you actually do not need an API key. So for whatever reason, Google has put out an open global API key that this module is able to use, right? So basically, it's making an API call. And it is using an official API key to make that call, but Google has just made that available and made that open so people can play with the service. Again, that's what a lot of these companies do. They make it free or incredibly inexpensive for people to play with something, And then as soon as you put it into a production environment, you find out exactly how much this crap costs. One of the warnings that I will give you with this, though, is that we don't know what the throttling of this is. We don't know what the limits are. I haven't run into limits. I've actually been using this for a couple of years now. I have never seemed, as far as I know, seemed to have run into many major issues using Google speech recognition with that basic API key that's provided with this in this module. But again, if you're going to put this in the production environment, you're going to start hammering the hell out of the system. Just keep in mind, you may hit some throttling, you may hit some constraints because they don't want you using this in a production environment for free. So that's one of the things. So basically, this is how we're going to turn the speech into text. Then, when we want our computer to be able to talk to us, the other service that we're going to use, or the other package that we're going to use, is called GTTS. Basically, this is Google's text-to-speech service. And with this, we're going to feed text to GTTS. It is going to turn that text into an MP3 file, and then we're actually just simply going to play that MP3 file, and that's what's going to get our computer talking to us. Again, this uses some weird API key that keeps working, so it seems to work fine, but if you run into issues, just keep in mind, right, you might actually have to pay for a real API key or something like that. One of the important things with this class is, again, this is not about building something that's going to go into a production environment. This is showing you how this works so that once you build something and once you understand how this works, then you can figure out the particular services, the particular API calls that you want to make in order to flesh out whatever it is, whatever project it is that you want to do. So anyways, that's we have the speech recognition and we have GTTS, and these are the core components of the project today. So now let's look at some snargly code. Again, I will warn everybody at home, trigger warning, trigger warning. I code like an MCSE in NT 4.0. And anybody who's been around for a while, they understand that joke. Anyways, everything that I'm going to be showing you when I build these things, do realize I'm focused on trying to present concepts to you, actually show you stuff that works. Some of the syntax and the formatting I probably wouldn't do in the real world this way, just because it might look a little ugly. But anyways, this works. It'll show you the concept. I'm not sure I'd copy and paste and give it to your boss. You might want to rewrite it a little bit if you're gonna try to copy this at home. So anyways, up here we have our shebang. So if we just want to be able to run this script without calling Python 3, we have the shebang up here. Then the first thing that we're going to import is the speech recognition module. So we're going to have to install the package for speech recognition. So pip3 install speech recognition, but that's all actually one word. It's speech recognition is one word, but that imports the speech underscore recognition module. It's just how it goes, right? Do remember, again, if you look at the documentation for this, to be able to import audio from the microphone, you do also need to install Pi Audio. Now, Pi Audio, installing Pi Audio, you know, that might be its own little troubleshooting routine. I've installed Pi Audio onto what I'm currently using here. This is actually a 2018 Intel MacBook Pro. I've installed it on here. I've installed it onto the M2 MacBook Pro. I've installed it onto Linux boxes. Installing Pi Audio onto different systems can be quirky. Can be quirky. So anyways, that is probably going to be the most difficult thing for you. If you do pip3 install Pi Audio and it works properly, or you do sudo apt install Python 3 hyphen Pi Audio, I think it is, and it goes well, then you're doing good. You might have to troubleshoot some stuff. I will just put that out there. Again, that's one of the difficulties with trying to teach this stuff online is, again, we're dealing with all kinds of different systems, all kinds of different configurations. Something as simple as installing a module can be a shocking pain in the butt. So anyways, Pi Audio. That's gonna be your most difficult thing for today. You're gonna have to figure that one out on Google. Anyway, so we have Pi Audio installed in order to be able to get the microphone. Then we have speech recognition installed so that we can get speech recognition. So this is the overall name of the module. So we're going to use an alias, right? An alias in Python. So as SR, just to make our life easier when we have to type this out. From underscore lowercase GTTS, we're going to import lowercase g, uppercase TTS, right? So basically from Google Text to Talk service, we're going to import this so that we can, turn text into speech. Import OS, this is what's going to allow us to interact with the operating system. From datetime, import datetime. This is what's going to be able to give us the time for when we ask for time. Import requests. So we're going to be doing REST API calls. We're going to be going out basically to websites, being able to pull information in so that we can do something with that. We're going to need the request module. Then we're going to import the serial module. So the serial module is what allows us to do serial communication to our Arduino. So we have that here. Then we come down, we're also going to import OpenAI. So when we do the joke, we ask a joke about Louis Rossman and Bill Clinton. We're going to be using OpenAI for that. Then we're going to come down here. We're going to have the OpenAI API key. I'm not going to show you my API key today, but that'll get plugged in here. So you either plug it in here or you'll plug it in as an environment variable. The secure way to do it is to plug it in as an environment variable. There's some documentation on how to do that in OpenAI. I do it this way just because it's easier to show you folks how this is working. R is going to equal sr.recognizer. So basically, the recognizer function within the speech recognition module, we're going to call that using R in the future. Language is going to equal English. Then we're going to come down here for the serial connection. So serial.serial. So this is going to be the serial connection. And this is how we're going to be connecting to the Arduino. So with my particular Mac, this is the line /dev/cu .usb modem 14101. Right? So if you are using a Mac, you go to the dev directory, you look for cu.usb modem, and then you plug in whatever that is, and this should work for you. If you're using Linux, this line would be TTY AMC 0 or 1. It's slightly different in the Ubuntu Linux world. If you're using Windows, I don't know what it is. You may have to do a Google search for basically serial connection between your computer and the Arduino. We set this at 9600 baud. So basically the Arduino is configured to be listening at a certain speed. So we have to make sure the speed is the same. Timeout after 1 second if it doesn't connect for some reason. And then we're going to flush. So basically we're just going to flush all the communication to make sure we don't send erroneous things to our serial connection. Then what we're going to go do is these are our functions. So we have a get time function, we have a get weather function, we have a get joke function, and we have a switch light function. So basically, when we say something, one of these functions will be called. So these functions are going to be before the while true loop. So normally, when you're running speech recognition, it will run once, it'll listen for whatever it is you have to say, and then it'll stop. So what we're going to do is we're going to do a while true loop on somebody else's API key. Again, one of the warnings in the real world. In the real world, be careful while true loops when you have to pay for the API key, right? So every time you make a request using an API key, generally it will cost, a penny or two. Right? If you do a while true loop, it's going to continuously hammer that API service. You're paying a penny or two literally as fast as this thing can loop. That can get expensive really quickly. So with none of this, am I actually paying for anything? So I'm not too worried about that while true loop. So anyways, basically what this is going to do is it's going to try to listen on the microphone. If it hears something, it'll process it. If not, it'll loop. If it hears something, it'll loop, 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 loop. So whether it hears something or not, it will just continuously loop and it won't stop until I tell it dismissed, essentially. So we come down here, we're going to have a variable called response, and we're going to set it to nothing. We're going to have a variable called phrase, and we're going to set it to nothing. Again, this is also looping. So one, it creates and sets these variables at the first time, but also as these variable values get set, every time we loop through, we want to clear out the variable values so that we're starting with something fresh. We don't want the exact same request, again, to start looping as fast as this thing can possibly loop. Anyways, so we're going to do this. So with SR, so speech recognition dot the microphone function, and since we have Pi audio, we can read from the microphone as source. We're going to print out on the screen, say something. Audio is going to equal r dot listen to source, right? So SR dot microphone as source, r dot listen. So up here, we have SR, R equals SR dot recognizer. So basically, what is going to be happening here is recognizer is going to be listening to the microphone and saving that to the variable audio. Now, the important thing to understand with this audio is at this point, the audio is just bits. It's not text yet, it's just bits. So then we're going to try. So again, remember in the Python world, try is like try to do something. And if it doesn't work for some reason, do something else. Again, when we're doing API calls, when we're interacting with the operating system, you want to use try a lot. So we're going to try to have phrase. So phrase, that variable we created, is going to equal r.recognize Google, that audio that's coming in. So the audio that came in from the microphone, right? We're going to try to recognize the text, and then we're going to set it all to lowercase. So that dot lower is a method. It's going to turn all the text to lowercase. Why do we turn all the text to lowercase? Because we have to parse the text, right? We have to read the text. Uppercase letters are different than lowercase letters, especially in the Linux world. So if we have a mix of uppercase and lower cases, or the computer thinks something is a name, so they make it an uppercase or whatever else, when we try to parse, we might run into some weird issues. So by changing the capitalization scheme to one standard for all the characters in the text, it makes our life easier to parse, right? So the audio that's going to come in, we're going to turn it into text, and we're going to make it all lowercase, and then we're going to print that out on the screen. Except unknown value error. Basically, it's going to say, I do not understand. Except request error as E, could not request results from Google Speech Recognition Service. And it basically tells you why, right? So if there's some kind of weird error, it's going to say, I do not understand. If there's a request error, then it's going to give you whatever the request error is. Then we're going to come down here to something that looks very simple. Isn't this simple? So easy. So first, we want the trigger word. We want a trigger word, right? Because remember, this is simply on, and the computer is simply listening. It doesn't know who's talking. Again, one of the problems we get into when we start talking about artificial intelligence is that it doesn't really exist. Right? When people talk about AI, they think about like human AI or dog AI or cat AI. Oh, it's AI. It's not as smart as a human, but it's as smart as a dog. No, 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 that's just not how this works, right? So, anyways, when this is listening, it is pulling in all of the words around it. So, if you have 10 people talking, if you have the radio on or whatever else, it's going to be listening to all of that, and it's going to be turning that into text. So, if you're trying to trigger based off of words and it's listening to all this crap, it's just never gonna shut up, right? It's gonna be one of the problems. So we want a trigger word. So this is, in the Apple world, hey, SIRI. I don't want to screw with your system, right? That's a trigger phrase. That's a trigger phrase. Google has their phrase. Microsoft has their phrase. So the cool thing here is we can put in whatever trigger we want. And so I'm just going to put in computer. So when I say computer, so if I say something, if I say something and it hears computer in that phrase, then it's going to start looking for some other words. If it doesn't hear computer in the phrase, it's not going to look for any additional words, and it'll just loop through, right? So basically, it'll only respond, hopefully, if I'm talking to it. If time. And so when you think about these triggers, this is the other thing you have to think about is what word or words or phrase do you want to trigger on, right? Nothing magically happens in the technology world. Somebody has to code all this crap. So, depending on how many different ways you want to be able to say things like time or whatever else, you will actually have to code that in so that the computer knows what to look for, right? So, I'm just going to do this very simple based off of single words. So, if time and phrase, so if I say computer and time, it's going to go to the get time function, and the response is going to equal the value that comes back. If weather, so computer and weather is in phrase, we're going to go to the get weather function and we're going to pull something back. If joke is in phrase, we're actually going to send the phrase. So when I say, tell me a joke about Louis Rossman and bananas, that entire phrase gets sent to OpenAI so that I can get that unique joke back, right? So with get time, I'm not sending anything. It is getting the value from the operating system and it's responding. Get weather, we're doing some what are called REST API calls, and it's just presenting back. With this, we're actually sending our entire request to OpenAI so that we can get that custom response back from OpenAI. Then we're going to have light. So if I say computer, light, we're going to send, again, switch light, but we're going to send the phrase too. So basically, we're going to set to switch light here. There's going to be an if else statement for if on or if off. And so that's going to be triggered. So we're going to send the entire phrase to that switch light function. And then if I say dismissed, so dismissed basically says turn off, break. So break will break out of the entire loop. Else, there's something else, we're just going to pass at this point. So pass just means keep on going. And then I'm going to print the response here. So whatever response I get back from these functions, I'm going to print that response out on the screen so I know I'm getting the response from the function, even if the computer isn't talking to me yet. And then we're going to go down here to GTTS, Google Text to Talk Service. So we're going to say try, and this is kind of like the standard. So my ob equals GTTS, text equals response, lang equals that language, that English that we said above, and slow equals false. My dot save response dot mp3. This is going to save into my default root directory. So it's going to save just into the Eli directory. And it's going to be saved as response.mp3. So again, depending on what you're building, you may want this to be a dynamic name. You get to design that. We're just going to use a static. Then we're going to do os.system afplay response.mp3. So there's an Apple File Play application that's built into Apple. And so I'm going to use this in order to play the MP3 file. And that's what's going to get the computer speaking to us. So this is something, again, depending on what system they're using, Ubuntu, it's like 321 MPG or something like that is the go-to. Basically, there's a whole bunch of different command line MP3 players out there. All you need to do is install one of them onto your system. And basically all we're doing is we're simply triggering that MP3 application to run and play this particular MP3. And that's what gives us the voice. And so this is simply the while true loop that goes through. And then after it loops, response goes back to nothing, phrase goes back to nothing. Now, one of the things that I will tell you, so I'm here in downtown Asheville, and Asheville gets a little bit loud, gets a little bit noisy. With this listen on the microphone, it will listen until it stops hearing sound or until it times out, which is something like 20 or 30 seconds. If you are in a loud environment, this whole system may come to a very slow crawl, basically because it's going to keep listening until it stops hearing anything. So if you have trucks in the background, if you have road noise, if you're in an office environment where lots of people are talking, then the sound level is going to still be high enough that it's going to keep going until it default loops out of it. And so that's one issue that you might run into. So if you're going to be playing with this, try to play with this in a quiet environment. And there's a whole bunch of stuff with how to deal with microphones and ambient noise and all that kind of thing. We'll play with that at a later date. That's one of the troubleshooting. So if you're using this and it like seems to be working, but it takes way too long, and then you realize the environment's pretty loud. That's a thing. Is basically it's listening to your environment. It's waiting for quiet, and if your environment is never quiet, then you might run into some quirks. Again, especially if you have like a loud HVAC system, you might run into some problems with that. Anyways, let me then close this while true or shrink that down, and we can go up and we can see the different functions. So the get time. So if I say computer, what time is it? All it's looking for is computer and time. It's going to go to the get time function. Current time equals date time now. Message equals string of current time, uh, string of F time. And what this does is percentage sign A gives you the day. Percentage time H gives you, or percentage sign H gives you the hour. Colon is just a colon, and percentage sign M gives you the minutes. So it'll tell you the day, the hour, and the minute. That is going to be turned into a string. So I don't want it as number or something else because it has to get spoken. That value is going to go to message, and then we're going to return message. So Friday at 2:15 is going to be the value of message as a string. That will then get returned, and we go down to the while true loop, right? So if time in phrase, so that message is then going to go to response, and then down here, response is going to get turned into an audio file, and then the time is going to be spoken to you. That's basically how that works and how this function works, right? So this is all very simple. Basically, you just get the time, you format the time as you want it. You don't want a lot of additional stuff. You turn it into a string, and then you return it. That's how you get the time. And then we go down here to weather. So with this, at the end of the day, we're going to be using Open Weather. So Open Weather has an API that's very easy to use. The issue is that we need the latitude and the longitude. So how are we going to get the latitude and longitude? Again, one of the things you have to be thinking about as a technology professional is you actually got to get this data from somewhere. Nothing magically happens, right? So basically, in order to get the latitude and longitude, so if we're using open weather, we need the latitude and we need the longitude. So how are we going to get that? So the first thing that we're going to do is we're going to use ipfi.org's API. This will get us our external IP address, right? And so our external IP address is for the premises that we're at, right? There's an IP address that actually connects us to the internet, and we want what that external IP address is. So that's all this call is going to get us. And so here we're going to get our IP address, and it's going to get turned into text. So text of IP address is IP address. And then ip-api.com, what this does is this gives you a whole bunch of information that's stored in a database about your external IP address, your latitude, your longitude, the city that you're in, the state that you're in, the provider that you have. There's about 20 different things that it basically stores in that database. So for IP data, we're going to do request.get ip-api.com, JSON, and then we're going to plug in that IP address that we got. And we're going to bring this back as a JSON value, right? So once we then bring it back as a JSON value, we can come down here. And so now weather is going to equal request.get API openweathermap.org data weather blah 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 lat equals IP underscore data, right? So this is a JSON value, IP underscore data lat. So that'll be my latitude. IP underscore data lon, that would be my longitude. And then we also need our API key here. One of the things, if you're going to be using the Open Weather API, is you also should add in units equals imperial, or whatever your particular units are. The default units that it uses is Kelvin. Why? I don't know. If you just use their stock standard, you just copy and paste their API call with lat long, you're going to get numbers that just do not make a damn bit of sense. And the reason is because you're dealing with Kelvin, I think it is. So anyways, you know, units equals imperial. You're going to feed it the API key. And then we're going to turn this into JSON. So when we get this response back, this will be JSON. So message is going to then equal, right, weather. So weather that we brought back, and then main, and then temp, right? So these are for in the JSON, the main, and then temp. That is going to get us what our current temperature is. We're going to be using an F string so that we can add degrees at the end. Again, this is going to be a message that we're going to be sending. So when we say 80 degrees, 39 degrees, and then we're going to return that overall message. And so this is kind of the step in something like a REST API call. First, you're going to get the IP address. Then you're going to get the geographic information about the IP address. Then, with that lat long from that geographic information, you're then going to get the weather. From there, you're getting a full JSON response. So then you need to figure out where the current temperature is and just pull out that specific information. So anyways, that's what the get weather looks like. Then we go down here to the get joke. Now you'll notice with these functions up here, get weather and get time, the parentheses, it's blank. Now with get joke, we actually have phrase in here, right? So with the joke, we want a custom joke. We don't want the same old joke all the time. We want a custom joke. So in order to get a custom joke, we have to send that whole phrase to OpenAI so that we can get a custom response. So with this get joke, all of this is the same standard OpenAI stuff I've been teaching quite a bit. Basically, you can copy and paste this from the OpenAI's API service or whatever. We're using GPT 3.5 Turbo model because it's dirt cheap. Role system, you're going to be a comedian. Role assistant, do remember to limit this. Remember, it might tell you a really long joke that a short bad joke is still funny. A really, really long bad joke is just horrible, right? So anyways, for assistant, we're going to say answer in less than 25 words. And then for role user, we're simply going to pass the entire phrase, right? So we're going to say, whatever that thing is, tell me a joke about, you know, Louis Rossman and Bill Clinton. That entire phrase is going to be sent to OpenAI. OpenAI is going to say, I'm a comedian. This should be answered in less than 25 words. Message is then going to equal response choices 0 message content. So you're going to get a JSON response back, and this is where what you care about actually is content, and then we're going to return that message, right? That's how that works. If we then go down to the light switch, so basically with the light switch, again, we have phrase, because we're going to send the entire phrase, because once we're in the light switch function, we still want to parse based off of, or we still want to trigger based off of what's in that phrase, right? So if we go down here, so if computer is in phrase, do one of these. If light is in phrase, do the switch light, send the entire phrase. And then here, what we're going to do is we're going to say if on in phrase. So turn computer, turn light on. Computer, light on. So on. So what we're going to do is going to try serial.write on. Next line in. Message equals light is on. Except pass. So for some reason this doesn't work, we're just going to pass. So if the serial write doesn't work, we're going to pass. So if on, we're going to try to serial write on to the Arduino. Then elif off in phrase, try serial.write off, message equals light is off, except pass. Else, message equals I don't understand what you want to do with the light. So if I say computer, turn light blue, that's not on, that's not off. So this is the message response that you would get back, and that is the end. So these are the different functions here. Beyond that, though, is with this, again, we're doing this whole serial write thing. So up here, we're creating a serial connection, right? So we have the serial module here. Then we're creating a serial connection using dev USB modem at 9600 baud. Again, we might have to do a Google search to figure out exactly what you need to put in there. And then we're flushing, but then we're doing the serial. From there, what we then look at is this is the actual code on the Arduino, right? So I have my Arduino down here, and this is the code that is running on the Arduino. Might actually have to make that even bigger, right? So with this, so on the Arduino, we're using digital port 3 as the port to turn on or turn off the relay. So the relay has wires that come to the Arduino, and this is what triggers it. So to define switch as digital port 3, we have string is command. We have the void setup, so this is where we set up the environment. Serial dot begin at 9600. So remember in that serial communication that we set up in Python at 9600, this is where we're setting up the communication here on the Arduino. Then we're going to do serial dot print line, type command, on equals on, off equals off. Pin mode switch, so digital pin 3 is switch, set it to output, so it sends information out. Then we're going to delay for 1000 milliseconds or 1 second. Then we're going to come down here to the loop, right? So in the Arduino world, this is not a computer, it's a microcontroller, it just continuously loops. You tell it to do something, it continuously loops forever and ever and ever. If serial dot available, command equals serial dot read string until that slash n. Read string until next line, and then command dot trim. So the command is going to be everything until the next line, and then we're going to trim off any white space. Because remember, we always got to trim off white space with these kind of things so that we don't run into weird problems, right? So here, right, serial dot write on slash n. So read until slash n. Or down here, serial write off slash n, so that's next line. So basically it'll read until that slash n. Then it'll trim off any white space. So this is comment. So for on, if command dot equals on, digital write switch high. So turn digital pin 3 on. If command dot equals off, digital write switch low, which basically means off. So with this is working. I can literally just go to serial monitor here. So I can go to serial monitor. Oops. Board at, let me get the board right. So go to tools. You might actually have to do this. Not programmer, port. We go to port. We go there. Okay, now we do serial monitor. Okay, so on the serial monitor here, it's set to all this, so we need to set it down to 9600. So I then set it to 9600. Let me just refresh my Arduino, turn it off and on. Okay, and now from here, what I can do is I can simply type on. See, I typed on, and it goes on. I type off, and it goes off, right? So from here, with this serial monitor, I can type in the commands in order to control this relay. All we're doing with Python is we're having Python send those serial commands to the Arduino instead of us doing this manually. So there you go. We build our own little voice-controlled Python application. This allows us to interact with the operating system. It allows us to interact with REST APIs. It allows us to interact with artificial intelligence, and it allows us to be able to turn things on or off. So what I really wanted to show you with this project today is how relatively easy this type of thing is. I know when you start getting the technology world and people start talking about artificial intelligence and speech recognition and IoT. It's like, oh my God, how am I ever gonna do it? Well, the way you're going to do it is because it's not nearly as hard as you think it is, right? Again, coming up with that speech recognition package, the person who developed speech recognition, that person is really, really, really smart. Me installing a package and then calling a module and getting text back, yeah, not so much. Again, OpenAI people. I will never denigrate how smart the OpenAI people are. That's not me. I'm writing 5 lines of code. I'm making an API call. I'm getting text back, and I'm doing something with the text, right? Uh, this stuff is a lot easier than people think. AI is hard. APIs are not, right? And so this is a lot of the cool stuff that you can do. And again, more of the projects that we're going to be doing this year. Again, things like machine vision, right? You can have either Azure's computer vision services or other computer vision services. You can literally send a video feed or an image, and it will just simply send you text back. So if you know how to plug in the code in order to make the API call, you can be getting that text back. And then again, you're triggering based off of relatively simple text. It's not nearly as complicated as you think it is. So yeah, so that's the particular project. So for this, again, if you're going to be doing this, the warning that I will give you is Pi Audio will either be really simple for you or a real pain in the butt. Can't tell you which. I don't know your operating system, right? If Pi Audio goes well for you, thank your lucky stars and keep going. If not, you might have some troubleshooting to do. That's just how the world is. The other troubleshooting thing to be thinking about with this is again, if you're in a loud environment, that might cause you some problems simply because when you trigger the microphone is going to keep listening until the noise level gets below a certain threshold. So if you have trucks, if you have traffic, if you have loud people, if you have a loud HVAC system, this whole thing might be quirky as hell because instead of you talking, stopping, it hears the silence and then it triggers, it'll just keep going essentially until it times out. And that's going to be an entirely different experience for you. So, that's just kind of how it is. Find a quiet environment, that type of deal. Beyond that, again, these are basic function calls. These are basic, if else statements. You got a while true loop in there. All of that is relatively simple. With this, if you want to do the OpenAI, you do need the Open API key. So you have to go to OpenAI and in order to get that API key, you give them their credit card information. And basically, do make sure to go in there. There's a limiting function. So with OpenAI, you can limit how much it's going to cost you. So for me, I actually set it at $10 a month, and I never go over $10 a month. So that's something you may want to set. You'll need to get the API key in order to do this project, and then you may want to set that limit. The other thing is that Open Weather. For Open Weather, there's a free service up to a lot of requests, but you also do need the API key from that. So if you want to be able to use that, go get your free Open API key or your free Open Weather API key in order to be able to get that weather information. But with the rest of this, the time and all of that kind of stuff, that should work for you. As far as the Arduino goes, this is basically just an Arduino Uno. So this is a 4 or 5-year-old Arduino Uno. That's all you need. We just have a single digital line that's connected to a relay. So I like this particular relay. It costs you about $30 off of Amazon, but it's nice because it's actually a nice plastic box. I don't have to worry about electrocuting myself or anything like that. But basically, the Arduino is then plugged into the relay. The relay is then plugged into the light, and that is what makes that whole system work. And yeah, that's about all I got for you. So let's leave this on a joke. Let's leave this on a joke. Here we go. Computer, tell me a joke about artificial intelligence and light bulbs.
Why did the artificial intelligence researcher buy a bunch of light bulbs? Because they wanted to shed some bites on bright ideas.
And as always, I enjoyed doing this particular class, and I look forward to seeing the next one.